In this problem, we want to determine whether the sequence converges or diverges, and if it converges, find the limit. Our sequence has the nth term defined by n plus natural log of n divided by n squared. So what we'd like to know is, does the limit, as n approaches infinity, of this term, n plus natural log of n divided by n squared, exist? If we think about what happens as n gets large, the top of this fraction will get large, and the bottom of this fraction will also get large. So we have an indeterminate form, infinity over infinity. The tool we have for infinity over infinity is L'Hopital's rule. However, we cannot take the derivative of the expression n plus natural log n because n is not a continuous variable. It's a discrete variable, which means that it only takes on the values 1, 2, 3, 4, and so on, and not any numbers in between. So what I'm saying is that L'Hopital's rule works only for continuous functions. Well, we have a theorem that says if this limit exists, then the limit is equal to the limit as x approaches infinity of x plus natural log x over x squared, where x is a continuous variable. Now on the surface it seems that we haven't done very much. All we've done is change the letter n into the letter x. However, we have an understanding that the variable n is a discrete variable, can only be a whole number, and the variable x is a continuous variable, can be any real number at all. Because this limit is indeterminate of form infinity divided by infinity, we can use L'Hopital's rule to rewrite this limit by taking the derivative of the top, which gives us 1 plus 1 divided by x, and taking the derivative of the bottom, which gives us 2x. Now we can simplify by splitting up this fraction. We have 1 divided by 2x plus 1 divided by 2x squared. And we know that each of those terms approaches 0 as x approaches infinity. So this limit altogether is 0. Our overall conclusion is that the sequence a sub n converges because that limit does exist, and the limit as n approaches infinity of a sub n is equal to 0. Language-wise, we can put all of that together and say that the sequence a sub n converges to 0.